And I'd now like to introduce our speaker, who is Nick Shcherbyna from the Musée Komputernych Technologii u Lwowie. And so, Nick, I would say, welcome to the foggy Albion for your talk. Too many Albion, and the floor is yours.
Okay.
That is good. Thank you.
Yes. So I hope screen sharing is working fine, and you see that blue and yellow flag, and the title of our today's talk: History of Ukrainian home computers, some maybe of Ukrainian personal computers. We'll see. Let me introduce myself first. So I represent the Museum of Computer Technology in Lviv, Ukraine. You see that red spot on the map of Ukraine. It is very west of our country. So in today's conditions, is considered rather a safe place. But it is not as safe as you might think, because if you hear that annoying sound, it is a power generator I'm running to keep our talk possible, because our electric power is off due to recent damage of Ukrainian electric power infrastructure. So I'm solving that problem on local level by running my own generator. But anyway, it is fine, as you can see me and hear me. And my name is Mykola in Ukrainian, but I prefer to use a short form Nick. And in cooperation with Ivano-Franko National University of Lviv, we started that project, the Museum of Computer Technology, because I was collectioner of vintage hardware for maybe about 20 years. And at some moment I thought that, it is not just a collection. I have to share stuff with people, start a museum, but how to do that? And fortunately, the university helped in this thing, provided the place for the museum. But even before that, starting at 2016, I started to present my collection of Western and East Europe vintage computers on various events, festivals. You see the picture from the Game Over Fest in Lviv, and started in 2016 at Decoded Computer Art Festival. So that was a thing till 2019, when we started cooperation with the university and opened that museum. You see the exhibits, Apple and IBM computers. Maybe not so interesting, because you already know what that stuff is. And here you see the people and some excursion in our museum. And here you see maybe nothing new, British computer technology, right? Acorn, BBC, and Auric, Atmos, and Enterprise 128, and Dragon 32, and other stuff. And here you see another masterpiece of British technology, Sinclair ZX Spectrum, all models, maybe except 128, and Timex Sinclair 1000, and other stuff. And here you see Soviets, maybe Russian computers. We will talk about a different thing today. We will talk about Ukrainian home computers. But let's start from 50s, the previous century. I think the previous talk about the Ukrainian computer technology unveiled the fact that the first fully operational electronic computer in continental Europe was created in Ukraine. And it was a MESM, or in English, a small electronic calculating machine. That machine contained about 6,000 vacuum tubes. And it was created, you see that spot on the map in the Laboratory of Computing Technology of the Institute of Electric Engineering of the Academy of Sciences of the Ukrainian Socialist Soviet Republic, under the supervision of academician Sergei Lebedev. And then, after that, the same team created the Kiev computer in 1956. It was an interesting machine with a speed about 10,000 instructions per second, and with 41-bit word fixed point arithmetic, and had 1K of magnetic core RAM memory, and you see the also read-only memory, and storage was on magnetic drums. So it was the second machine, and I'm just describing that ancient history to show the fact that further developments in Ukrainian computer technologies were based on some solid background. Yes, because we created the first electronic computer in the continental Europe. But maybe I see my colleague Yuri Yushchenko here, and he is an expert in that early years of Ukrainian computer technologies, and I'm more interested in the personal computer era, started in 1970s, and it started with the simple thing with a clone of Intel 8080 CPU that was created in Kiev, the capital of Ukraine, at the Scientific and Research Institute of Micro Devices. And that work was supervised by Alfred Kobylnitsky. So you see two ICs here, two chips, and at the left it is the original Intel 8080 CPU, and at the right it is the so-called KR580 VM80A. It is the Ukrainian, or we call it Soviet clone, but it was created in Ukraine by that team. And what they really did. They split it apart, the original Intel 8080 CPU, and took 36 photos of silicon using an optical microscope. And then they projected these photos on paper with a scale of 5 micrometers to 5 centimeters, that is a scale, and highlighted the layers by red, blue, and green pencils corresponding to P and semiconductor and metal layers, respectively. And they created that model of the original Intel 8080 chip, and it was processed by the Soviet BESM 6 supercomputer. It is something like, that CDC machines designed by Seymour Cray, very similar in power and architecture. And then they figured out that the design of Intel 8080 is not perfect because some transistors were close to overload, and they fixed it. So it is not just a clone, it is an improved clone. And then some design issues were fixed and design updated to match the Soviet technology process to produce these chips. And here you see the map of Ukraine. These CPUs are 580 Intel 8080 clones were produced at the factory Crystal in Kiev, Quasar in Kiev, Rodon in Ivano-Frankivsk, Western Ukraine, Quantor, Zbaraj, Ternopil province, Western Ukraine as well, and Dnipro plant, Kherson. And only one factory produced these CPUs in Russia. So Ukraine was a high-tech center in the Soviet Union in early 80s. And then the same team developed a completely new CPU, KR 580 VM1. It was improved version of Intel 8080, but not in the Zilog Z80 way. It was a totally different thing, not compatible with Western processors. Our engineers introduced the second 64 kilobyte memory bank and some instructions to access this bank using a new register pair H1L1. So it is a very rare and interesting CPU. And then the same team cloned the Intel 8086 and Intel 8088 family, CPUs used in IBM PC and clones. And the clones are named K1810 VM86 and K1810 VM88, respectively. And these clones were also produced in Ukraine. So these guys created a solid base to create some personal computers using these clones of Western CPUs. And what happened then? I have to tell about some background of communist computing first, because in the Soviet Union there was so-called plan economy, and the only Communist Party defined what computers are needed for people and how many and what model. And they decided that there is this funny computer, Electronica BK0010, designed in Leningrad, Russia. It's an interesting machine, in fact, because it uses the 16-bit CPU K1801 VM1 running at 3 MHz, and the RAM is just 16K, and another 16K is for graphics. Not so bad. You see 512 by 256 monochrome pixels. And the programming language was not a basic, as one might expect, but it was a focal for some reasons. And it was a rather expensive machine. It cost 600 rubles. I think the salary of an engineer in the USSR was about 200 or even less. So for obvious reason, people were trying to find their own home machines. It was hard to buy that BK0010 computer. And now I will tell you a rather funny story. In 1978, samples of the K580 CPUs, if you remember, is the Ukrainian clone of Intel 8080s. So these samples were sent by the Crystal factory in Kiev to some institute in Moscow, Russia. I don't know, maybe the postman was drunk, but he delivered these samples to another institute, to the Institute of Electronic Control Computers. Not a big difference. Electronic Machine Building Institute or Electronic Control Computers Institute. And that funny mistake initiated a very interesting process, because engineers at that wrong institute figured out it is a CPU, an Intel 8080 clone, and they designed the computer based on that CPU. But it was the absolutely crazy design containing 200 ICs, 200 microchips. It is just too much. And they published the schematics in the radio magazine, but as you might guess, it was almost impossible for an ordinary engineer, do-it-yourself enthusiast, to build such machine containing 200 ICs. So they decided to change the design, to simplify it, and turn into just 29 IC version. It called that Radio 86RK, and published that design in the same magazine, Radio, in 1986. But the trick was that they used sophisticated CRT controller IC, the IR 580 VG75. It was actually a Intel 8275 clone. And it was very hard to find cheap. But anyway, you see the characteristics of that home computer design. So the CPU is 80-bit Kyr 580, the Intel 8080 clone running at just 1.78 megahertz and just 16K RAM, 2K read-only memory with monitor firmware, no ROM basic, and that's hard to find video chip, no graphics, no color, just pseudo graphics, and sound was just a 1-bit beeper. So here you see an exhibit from our museum, the do-it-yourself version of that Radio 86RK, and here you see the schematics of that computer. So not so simple, many different chips, and also you see the ROM font. And the fact is that some character is Cyrillic SP. That means Sergei Popov, the engineer who designed that machine. But it was more about Russia, not about the Ukraine. So how this design is connected to Ukraine? First, many do-it-yourself versions of Radio 86 computers were made by Ukrainian enthusiasts, but also the Radio 86 compatible machines were produced in Ukrainian factories, and you see these versions here on the screen. At the left, you see that radio magazines showing the schematics of the computer, and some physical implementations. So let me talk a bit about these implementations. First one is the UMPK R32 manufactured at the Mukachev Prilot factory in Zakarpattia province, western Ukraine, and also that's solid metal thing called Quasar, manufactured at the Iskra Telecom equipment plant in Lutsk, and also that Alpha BK manufactured in the Odessa province in Izmail on the ethylene plant. Also, you see the solid metal device. And let me show some games running on that platform, Radio 86RK. At the left, you see the game known as Python. So today, Python is a programming language, but then it was a game. And maybe it is very like, that Snake game on the Nokia phones, the same idea. And at the right, you see the chess game. So it looks somehow strange, but it is due to that pseudo graphics, no graphic mode, if you remember. Actually, not so bad. And then the Ukrainian engineer Anatoly Volkov from Dnipro-Dzerzhinsk, now Kamensk, in Dnipropetrovsk province in Ukraine. This is eastern Ukraine. He designed in 1985 his own version of a home computer called Specialist 85. And that computer contained only 59 ICs. So that man was a genius, like maybe Steve Wozniak, because the computer contained just 59 ICs, but provided a high-resolution graphic mode. And that schematics was published in 1987 by the Modelist Constructor magazine in the USSR. And the original name of the machine was Fachives 85, that means specialist 85 in Ukrainian. But of course, they renamed it to Russian, called for some reason, specialist called the same in Russian and in English. Anyway, here you see the schematics, and the CPU was the same KR 580 Intel NT80 clone, running at 2 MHz and 48K RAM, including 12K of video memory. And again, the read-only memory containing only monitor firmware, not basic, but graphics was not so bad. 384 by 256 pixels, monochrome pixels, and then some extensions were designed and published in that magazine, providing 4 or 8 or even 16 colors for that machine. The sound was primitive, 1-bit beeper. And in our museum, we have the factory-made version of that specialist computer called LIC, that in translation means individual computer. So you see that cheap keyboard, very common to cheap PCs of that era. But anyway, here's the difference in gaming on that specialist and the Radio 86RK. So it is monochrome graphics, but it's high resolution graphics. And at the left, you see that Buran Soviet space shuttle, right? And at the right, there is some Load Runner-like game. So not so bad, actually. And then let me talk about the personal computer designed in my city, in Lviv. The computer was manufactured at the Lorta factory, and it was designed by Mr. Volodymyr Puida from Lviv Polytechnic Institute. I know this man. He's still alive, and sometimes we discuss various things. So here you see the pre-production prototype of that model, and again, it was running as most of Soviet computers on that 8-bit KR 580 CPU, running now at 2.5 megahertz, and the RAM size was 64K, including 16K of video memory, and also this machine finally contained the BASIC in ROM, yeah, and the graphic mode was able to show 4 colors from 8 color palette, and the resolution was 256 by 256 pixels, but only a subset of this area was usable. You will see it now. So at the left, you see that palette. Actually, it is better than IBM CGA, right? You have more options to choose from. And also, let me show that right video again. A nice animated splash screen, very uncommon to the computer. So that there maybe only MS6 machines provided such splash screen. So this really nice thing. And here you see the basic prompt, and the basic was based on Microsoft Basic. It is very easy to tell why, because error messages are 2-letter message like BS error, SN error. So it is like the early versions of Microsoft Basic with roots maybe from, that Altair era, very early versions. Also, that computer contained an Easter egg. If you press a specific combination of keys during the reset, it calculates checksums of ROM chips. And if you then press another secret key, it shows you that copyright message. That means that it's copyright by Lviv Polytechnic Institute in 1989. And here you see examples of games on that computer. Maybe this some acid-like colors, but remember, just 4 colors from 8 color palette. The first thing, and the second thing, that many developers were using monochrome displays. So they were unable to see how the game looks on a normal color display. And here we see the same game, jumping jack on the ZX Spectrum platform at the right, and the port to Lviv computer at the left. So not so bad. And here you see a more sophisticated example, the international karate game. Of course, it is not an official clone, as you might guess, but the same idea. So Commodore graphics looks very good, of course, but that version on the left is also not so bad. And now we raise an obvious topic about the programmers who created these games, right? So another game is Popcorn, and that is some space game. And there was bedroom coders movement in Great Britain, in early 80s with the rise of ZX Spectrum, Acorn, and other computers. So people were writing games in their bedrooms, selling and starting small businesses. Oliver Brothers, it was somehow the same here in Ukraine. So we had bedroom coders as well. And for example, the game at the right is written by my classmate. And the game at the left is written by another guy, but I know him. And here you see the another game written by my classmate, and at the right some source code in BASIC. This game is written in extended BASIC, so there was some assembly language program loaded before, and then it added some sprite graphics and sound effects to standard BASIC and made writing games easier. But what happened then? So my classmates developed these two games and sent these games to some company. Remember, it was the Soviet Union. And so sent these games to some company in Moscow. And they said, oh, nice game. But they didn't pay anything to my classmates. However, they sold these games. So he invested his time and efforts in writing this game and get nothing in return. So that is the difference. Of course, there were more successful examples, but it was really a problem. Yeah, that's license issues, not having the normal software market here, and it borrowed many efforts. Okay, anyway, the British ZX Spectrum computer has is a very significant thing for Ukrainian computer history, and that is why. In 1985, three engineers of the Experiment and Design Bureau of the Lviv Polytechnic Institute took the original ZX Spectrum 48 for about 5 or 6 hours to investigate the schematics of this machine using the oscilloscope, especially the signals of the ULA chip of that spectrum, uncommitted logic array chip. These three engineers were Yuri Dobush, Ivan Natata, and Oleg Starostenko. And you see at the left the schematics of the ZX Spectrum E1. So that yellow rectangle is the ULA, uncommitted logic array chip, that contains maybe 50% or even more of computer functionality. Mostly the screen output, but also some other stuff. And these engineers were able to reproduce the same functionality using the regular ICs that were produced in Soviet Union. And at the right, you see the equivalent schematics actually with much more ICs. So it does the same thing in a more sophisticated way. And it was the first ZX Spectrum clone ever in the Ukraine, and even in the former USSR. So they shared that schematics, and some do-it-yourself enthusiasts were able to solder chips and create their own home computers. For example, here you see the ZX Spectrum clone version designed in the case of Leaf computer mentioned before. But also, manufacturers started to produce ZX Spectrum clones here in Ukraine, and you see such machines on this big picture. And at the center, at the bottom, you see the Lviv PCB. And at the left, you see the schematics just shown you in my presentation. And other machines are do-it-yourself or factory clones. For example, this one called Robic was manufactured since 1989 in the Rotor factory in Cherkasy. It contains Cyrillic letters on the keyboard, as you see, and also the arrow keys were mapped to Kempston joystick. Another clone is Oriel BK08 that was manufactured since 1990 at the Dniprovsky machine building plant in Dnipro, Ukraine. That machine had a shadow RAM and the NMI button. NMI means not masked interrupt, so the hacker was able to load the debugger into that shadow RAM, and when he presses that NMI button, control is passed to the debugger, and the hacker was able to debug some software game or whatever, and maybe add some leaves or shields or bullets, whatever, you know. And this one is marketed as a video game console, but of course you see 40 keys, yeah, in very cheap version, but still it is obviously a ZX Spectrum clone. So many ZX Spectrum clones were produced by factories. Here I show only 3 examples, but there were, I think, dozens of these machines, at least, and even more do-it-yourself clones. Now let me tell about other branch of home computing, a very strange family of Junior and Argo machines developed in Kiev. Here you see this computer and the hi-fi tape recorder. So why we see that strange combination of devices? Because that hi-fi recorder has a wired remote control interface. And both Junior and Argo computers were able to control this hi-fi tape recorder using that wired interface. By the way, the tape recorder was produced on the MEOC factory. In English, MEOC means lighthouse. And today, that factory produces machine guns, mortars, and other nice stuff that eliminates the Russians. So that hi-fi tape recorder was able to fast forward or rewind the tape with a rather high speed. And they used that fact to emulate the disk using the magnetic tape. So they provided a special software to format the tape by marking some sectors like on the floppy disk. And these machines were able to run CP/M operating system using that disk emulation. So they used cassette tape as a floppy disk. Of course, it was much slower than a normal floppy disk, but it worked. And in addition, the Argo computer was based on Z80 CPU, and they implemented the ZX Spectrum compatibility mode. So to run ZX Spectrum software, first you have to load some system program, and then it reprograms hardware in a very specific way. By the way, the hardware was based on, if you remember my previous talk about the Radio 86 machines, it was based on that CRT controller, yeah, Intel 8275 clone, but they created some masterpiece of engineering that was able to implement ZX Spectrum compatible graphic mode using that CRT controller. Is absolutely crazy. So the only problem is that these machines appeared too late. Everyone was interested in IBM PC compatible machines and professional software. And that requirement was satisfied by the Poshuk 1 machine. In English, this Poshuk is search. So it was a PC-compatible computer manufactured at the Electron Mesh factory since 1988. This machine was designed by the Yuri Roll. You see that engineer, and the cheapest version was, you see, that all-in-one computer with just 128 kilobyte of RAM and power supply, and you need a TV set and a tape recorder to make it work. But there are 4 extension slots. In fact, it's a compatible logically, but not physically. And here you see different adapters inserted in these slots. So these adapters were first RAM extensions to a normal 512 or 640 kilobytes, right? And also printer, serial port, and whatever else, even joystick connectors. And this machine, it was PC compatible, but contained just 80 ICs. So how it works with just 80 ICs? It is an interesting engineering masterpiece because the IBM CGA adapter provides separate text and graphics modes. And in this Poshuk 1 machine, physically, there was just a graphic mode, and text modes were emulated. So if a machine is in the text mode and you write some character code into the graphic memory or some attribute, Then a non-masking interrupt calls the corresponding routine in the read-only memory that renders the corresponding character in the graphic memory. This is the absolutely crazy thing, but it worked. And I think 95% of IBM PC software was compatible with this machine. And just 80 ICs. It is actually a masterpiece of engineering. So here you see rather a complete system with all 4 slots occupied by various adapters, and the joysticks and the color monitor. But then they designed the next version, the POSHUK 2, that looks like an ordinary IBM PC compatible machine. And it is such machine. The only difference is that motherboard was based on Ukrainian, or if not Ukrainian, Soviet chips. So here you see a close-up of the CPU. Remember that K1810 VM86 clone of the Intel CPU, and all other ICs were made here in Ukraine. And in the early 90s, this machine was cheaper than clones coming from Taiwan or whatever. And this machine was not so bad. If we compare with IBM PC XT, you see it is more than 50% faster for an obvious reason. It is based on Intel 8086 clone. So the CPU with 16-bit bus, not 8-bit bus, right? So that is why it is faster and also a higher frequency. And this machine is a strange thing that lays between IBM XT and IBM AT, right? It even has the BIOS setup utility and CMOS memory, like AT machines. And let me show another PC XT compatible machine made in Ukraine with a totally different approach. So this machine is, I think, 100% compatible with IBM PC XT. And this based on what we call today a chipset. So 5 ICs, something like the ULA, yeah, in ZX Spectrum. So that is it. So it is the end of my today's story, and let me return to 2024 and tell a rather sad story about the computer museums of Ukraine. Maybe you know that computer museum in Mariupol was totally destroyed at the very beginning of this war, right? 2 years ago. And at the right, you see the computer museum, the Software and Computer Museum in Kharkiv, that you see secured by some panels. And they opened after that. The picture is from 2022, but these days it is closed again. Thank you. Thank for your support and stand with Ukraine. Thank you very much. And if you have any questions, I'll be happy to answer.
Dziękuję za lekcję. And are there any questions?
Mykola, can you please tell a bit more about museum in Lviv?
Oh, sure. Thanks. The museum in Lviv is a joint effort of Ivan Franko National University and me as a private collectioner. And I donated actually the whole, maybe not the whole, but 90% of my personal collection to that entity. And for a simple reason, because the Lviv University already has several museums, including well-known, for example, Zoo Museum. It is well-known in Europe with one of the largest collections. So it is a proper place for such a collection of computer equipment. And we started cooperation in 2019. And then there was a COVID and then that war. But anyway, we are operational. We have that some rather small place like 50 or 60 square meters occupied by a lot of computers, and I conduct excursions. So that is the story. We hope to extend to move to a larger place. We have such ideas, but maybe not this year. So if you want to visit our museum, please join our Facebook page and contact us via Messenger, and we will organize such the excursion.
Mykola, there is a few questions on the chat as well.
Okay.
The first question being printers for the early systems, the early kits.
Okay, I see the chat. Printers. Yes, our exhibits are not only computers, but also peripheral equipment, and we have some printers in our exhibits, dot matrix printers. For example, in ZX Spectrum stand, we have that nice small ZX printer. Who designed the black jukebox computer? Black jukebox computer? I have no idea. A black jukebox computer. I have no idea what that's about.
Katie, can you please narrow your question because we can't catch it? And by the way, in general, in Soviet Union then, there were not.
It was black mostly with yellow and looked like a jukebox. Black with yellow. Okay, let me try. Let me try to share my screen.
This one, Kathy?
I actually have no idea. It looks like a replica of some arcade machine, and it is from the Mariupol Museum. It was destroyed by the beginning of this war. So I have no idea. It is just a picture of Mariupol Museum. It not belongs to my museum.
It seems there are no other questions. So I guess we can close this call. Dziękuję znowu. And goodbye to everybody.
Well, thank you very much. I hope eventually we will win this war, and everyone will be able to visit Lviv and visit our museum.